Alcohol A was used to form ester B via an acid-catalyzed esterification reaction with benzoic acid. So let's just start with this first sentence and interpret this into an actual reaction. So it tells us that we are forming an ester B and that is the product, and that we are doing an acid-catalyzed esterification with benzoic acid. So this is what the process that we're looking at. So here is benzoic acid. And it tells us that we are reacting this with an alcohol, and they're calling that alcohol A. So I'm just going to put an R group on there because we don't know what the alcohol is. And so this is the alcohol A. And it's telling us that we are doing an acid-catalyzed esterification reaction. So that means we got some kind of acid catalyst in there and some heat. And this is also known as a Fischer esterification. And so we are making an ester. So our ester is definitely going to have a lot of characteristics of the benzoic acid. It's going to be some alcohol, alkyl benzoate. So it's going to have this general structure. So OR, okay? So this portion of the molecule is coming from the benzoic acid. And then that OR portion is coming from the alcohol. Okay, so it's this portion of the alcohol. All right, and what's being lost from the benzoic acid is the OH. It ends up getting lost as water. So we're just keeping this portion of the benzoic acid is what's going to make your ester. And so what we have here is that we have, if we go to the next sentence, it tells us that we have the proton NMR spectrum for the ester B. So we have the proton NMR spectrum for the ester, and then from that structure of the ester, we need to backtrack and get the structure of the alcohol A. Okay, so it might be worth drawing this general form of the benzoate ester on our spectrum. And since it is a benzoate, we should be able to easily pick out the protons that are associated with that benzene ring. And then we know that those are coming from the benzoic acid, and the remaining signals are going to be coming from the carbon and hydrogens, well, the hydrogens because it's proton NMR, of the alcohol, right? So on your benzene ring, you have 1, 2, 3, 4, 5 aromatic hydrogens. And what we see here, this is our aromatic region. We see 2 hydrogens and 3 hydrogens for a total of 5 aromatic hydrogens. And so you might look at that ring and expect to see 3 signals, because I would expect these 2 to be the same, and then these 2 would be another signal, and then this last one. But what we're seeing here, I think, is these 2 hydrogens are this signal, and the remaining 3 is coming up here. It is probably 2 overlapping signals. You can see it's pretty messy. But the key here to this problem is recognizing that these are the aromatic hydrogens, so that if we're looking for the structure of the R group, we are not looking at those signals, we're looking at the remaining signals. Okay, so we want to know the signal that is attached to the oxygen. So one thing we should remember is that in proton NMR, if you have hydrogens on a carbon that's attached to oxygen, then the chemical shift for those hydrogens will be somewhere around 4 parts per million, right? So that's the scale on the bottom. So we can say that this signal here, these are the signals for the hydrogens on that carbon that's directly attached to the oxygen. So that's good information because then we can build from there to see what the rest of that R group looks like. So because of the chemical shift, so the chemical shift here tells us these are next to the oxygen. Okay, so we can start building our molecule. So let me go ahead and start drawing again here the ester. So we have the benzene ring. We have the carbonyl. we have the oxygen. Okay, and so what we're doing is we're starting to build off of this oxygen. So it tells us that these are the ones that are next to oxygen. When we look at it, it's 2 hydrogens. So this is most likely a CH2 group that is attached to that oxygen. So we say, okay, we probably have a CH2 attached to that oxygen. And then these signals are probably going to decrease as you move farther away from that electronegative oxygen. So we can logically kind of just move away from it going down in terms of chemical shift value. And we're also going to pay attention to the splitting, which tells us what is next door to what. So we also notice that this is a triplet, right? This CH2 is a triplet. So that means that the neighboring carbon must have 2 hydrogens. Right, so we're using the n+1 rule there, right? Like 2 + 1 is 3, and that is a triplet. Okay, so this is probably next door to a CH2. And if we look at the next signal, right, because we said we expect as we move away from the oxygen, we're just going to gradually decrease. We see again that we have 2 hydrogens. So there's 2 hydrogens. And then we see that this one is split into a sextet. It has 5 neighboring hydrogens. So we'll just say 5H neighbors to keep it short. So we can see 2 of them here. That means on the other side there should be 3 hydrogens. So again, we'll look to our next signal and we see that that signal is 3 hydrogens. Right. So I guess I should put in that this is a CH2. That's what the 2 hydrogens tells us. And then the sextet tells us about what's next door, a CH2 and probably a CH3. And here we see 3 hydrogens. So we do indeed have a CH3. And it is a triplet, which means it has 2 neighbors. Okay, 2 hydrogen neighbors. So that means that on the other side of it, it is a CH2 like this one. So we have our chain, right? So I am going to go ahead and just number these signals. So 1, 2, 3. I'm not numbering the benzene ring. I know where that is, and that wasn't part of my alcohol. So I'm saying that these 2 hydrogens are the signal for 1, these 2 hydrogens are this signal, and these 3 hydrogens are the final signal. And so from this, I can look and say, well, what was the structure of my alcohol? Well, I know that this portion came from the alcohol. So that means that my alcohol was the straight chain propanol. Right? So this must have been my alcohol in order to get this structure for an ester. And so that means that the answer here is A.